Welcome to The Explainer. So today, we're diving into a really fascinating shift happening in technology. See, powerful AI is starting to break out of the cloud, out of those giant data centers, and it's moving into the physical world all around us. We call this Edge AI, and it's all about running that intelligence right on the device itself. I mean, just stop and think about that for a second. What if a simple webcam or the camera on a little robot didn't just capture images but could actually look at a scene and reason about what's going on? This just opens up a whole universe of possibilities for devices that are genuinely smart. And what's really wild is that this isn't happening on some massive server farm miles away. It's happening right here on a piece of hardware that can literally fit in the palm of your hand. Which, of course, brings us to the big question for this whole explainer. To really get our heads around that, we're going to break this amazing tech down into three key parts. Think of it like this. You've got the brain, the body that it lives in, and then the process that brings it all to life. Okay, so let's start with the brain. What exactly is the AI that's making all of this possible? What are we really talking about here? Well, we're talking about something called a vision language model, or VLM for short. And this is a huge leap forward. See, older AI might just categorize things. A VLM, on the other hand, it blends what it sees with an understanding of language, so it can actually interpret the context of a scene and even talk to you about it in plain English. And this slide really nails the difference. A traditional model looks at a picture and spits out a label, like cat. But a VLM can look at that exact same scene and say something like, there's a fluffy orange cat napping on a red pillow. It's the difference between simple recognition and actual comprehension. It's a game changer. Now, the specific VLM we're focusing on is NVIDIA's COSMOS Reason 2B. This thing was built from the ground up to be super efficient and have really sharp reasoning skills, which, as you can probably guess, makes it the perfect candidate for running on smaller devices, which leads us right into our next section. All right, so let's move on to the body. We've got this incredible AI brain, but what kind of hardware does it run on? It needs something specialized, something small but also powerful enough to handle it. And that's where the NVIDIA Jetson family comes in. The best way to think about these is as a lineup of mini supercomputers. They are purpose-built to take AI out of the data center and put it right into the real world, inside things like drones, robots, and smart cameras. And as you can see, one size definitely does not fit all. You've got this whole range. At the very top, you have the AGX Thor for some really heavy-duty AI research. Then you've got the AGX Orin, which is great for professional prototyping. And then there's the one that's perfect for what we're talking about, the Orin Super Nano. It's compact, but still incredibly capable for these kinds of edge AI jobs. Okay, so we have the brain, that's our Cosmos model, and we have the body, that's the Jetson computer. So how do you actually put the two together? Let's take a look at the high-level process for bringing this AI to life. Now, the full technical tutorial gets into all the details, but it really boils down to these four main steps. First, you just download the AI model. Then you set up this special software environment called a Docker container. Think of it as a neat little box with everything the AI needs to run. After that, you start up a server to, well, serve the model. And finally, you connect a simple web interface so you can actually talk to it with a webcam. But, of course, it's never quite that simple, right? This quote from the source material really gets to the heart of the challenge here. Trying to run such a powerful AI on a device with very limited memory, well, it's a tight squeeze. You have to be pretty clever about it. And this is how engineers do it. They use these very specific commands, or flags, to manage the device's resources. Think of it like carefully packing a small suitcase for a really long trip. For example, one flag tells the AI to only use about 65% of the memory, just to leave some breathing room for the operating system. Another one limits the AI's short-term memory, so it doesn't get overwhelmed. Each one of these is a careful trade-off between performance and the limited resources you have to work with. Okay, so we've looked at the brain, the body, and the process. Now that we kind of get how it all fits together, let's just zoom out and think about what this all really means for the future. So why does all this matter? Well, it means that developers can now build and test real-world AI applications so much faster than ever before. We're talking about things that used to feel like science fiction, like a search and rescue drone that can just describe what it's seeing in plain English, or a smart checkout that actually understands what's in your cart without having to scan a single barcode. And what's really amazing is that all of this is powered by an incredibly sophisticated AI model that's been shrunk down to just about 5 gigabytes. I mean, that's small enough to fit on a cheap thumb drive, but it's powerful enough to reason about the world around it. So you see, at the end of the day, this isn't just about one cool model or one tiny computer. It represents a fundamental shift into a new era of AI that's accessible and physical. And that really leaves us with a pretty exciting question to think about. When the everyday objects all around us can finally see and reason, what are we going to create?